Hello everyone, today I wanna solve this problem. We should find the electric field and the center of hemisphere. So let's start. Firstly, we find a small part of this circle, and this circle has with the x. It's a very small amount of distance, and we have we have a radius r. So our dx will be r multiplied by we have a very small angle detector here, delta, and then we have our height. Let's mark it is as x equal to r cosine theta. Then y. Let's find area of this little amount of area here. It would be the x. It would be the x multiplied to be r sinus theta, because we have our use of this little amount of hemisphere, and we multiply to the dx, and then we have a very small amount of charge that is equal to sigma multiplied by little amount of our area, and it will be sigma multiplied by 2πr sinus theta, and radius that angle, and it's our small amount of charge in the area. Then I guess we have this little amount of area, and it will form a ring, some kind of ring. We should draw this. Okay, and we should find the electric force at height x from its center of the ring, as x components of this our total would be 0. Okay, and we should find the net component of our electric force from that ring. Then we find that our electric field will be multiplied by cosine delta, and our cosine delta is equal to x over r radius. Then radius we take from our hemisphere, because each part of this hemisphere is located in radius r place. It's an electric field of very little amount of area that forms a link from our hemisphere. Okay, then we can find that our delta is equal to charge multiplied by k, and over r square, and from our charge is it won't change, so it would be just as q over r square, and our electric field Ay is equal to kq square over kq, and over r squared multiplied by cosine delta, and then we should find the total force, total electric field, I think, on the center. So we should sum all the little rings of this hemisphere. Our A would be equal to q over r square cosinus delta. It's from one circle, and then we should find all amount of fields of each. So we should integrate it. Then we place the the q from our beginning formulas, then and it would be sigma, it would be k multiplied by sigma multiplied to r sinus delta and multiply r theta delta, and divide r square, and now r square would be distributed and we have only k sigma p to p sinus delta cosinus delta t delta from this expression. It's clear now that 2 sinus delta cosinus delta would be equal to 2 sinus 2 alpha. So we place in the place just k sigma p multiplied sinus 2 delta d delta. So let's integrate because we have the same equation, and we integrate from 0 to p over 2 because we should find all rings, and the rings are located from 0 to p over 2. Then we integrate it. Integration of sinus 2 delta would be equal to minus cosine 2 delta. So after placing our integral 0 to p over 2, we can find that in 2p over 2 our equation would be to 1 over 2 minus, and we put 0, it would be minus 1 over 2. When we sum of them it would be 1, so we just write E equal to sigma p over 4p is 0, and we can write at is 1 over p. 4p is 4p e equals 0, so our total electric field would be sigma p over 4p is 0, and it is 0, and it would be sigma divided by 4 e0, and it's our final answer, I guess. I think this problem was clearer for you. Thanks for listening for me, thanks for attention for me. Bye bye.